Thank you for joining us today. My name is Dan Wildenhaus. I'm an indoor environmental management professional from Atmosphere Incorporated. Today we're going to be talking about blower door testing, why it's important, why we do it, and how it affects our new houses. So let's go inside and take a look. Okay, now we're inside the home. We're going to talk about why we actually do the blower door testing. We do the blower door testing for a couple of different reasons. First is to actually verify that we're meeting the targeted air changes per hour designed for a home. The second is because we're also going to want to be able to look at, are we controlling where the air is coming from in and out of a house? It's one thing for a house to leak the proper amount. It's another thing to decide where that air comes from. My favorite quote is that air is like a teenager. It doesn't go where you want it to go necessarily. It goes where it wants to go unless a force is acted upon it. The reason that we really want to measure the leakage in a home is there's many different forces that work on a home that move air throughout the house, whether we want it to or not. There are several effects such as stack effect. That's where warm air is going to rise in a building. The taller the building, the stronger this effect is going to be. What happens to this? This means that warm, humid air from the house is going to exfiltrate. It's going to work its way up and find ways out. And it's going to want to bring cooler air to make up for it down in somewhere lower in the home. Obviously, this can pose problems for both air quality if we're bringing air in through the crawl space or the garage. It can also, bring in colder air than we would like to have in the house. The second major effect is what we call mechanical effect. Standing here in the kitchen, if I were to turn on kitchen fans, for example, that's going to be exhausting air out of the house. When that happens, air has to come in from somewhere else. Again, the better we can control and tighten the house and decide where that air is coming in from, the better off we're going to be from both an energy standpoint and an indoor air quality standpoint. Then we also have other effects such as wind effect, other natural things that happen on a home, the pressures that are put on the home, doors being opened and closed, wind being pushed onto the building, they're going to affect how air leaks in and out of the house. By doing blower door testing, we can actually verify that the home has been air sealed in the right way. And we'll go through that. We're going to take a look at some areas where we're going to want to do some air sealing in the house and find out where are the places we want to tighten up so that when we do our blower door test and we say, yes, we've achieved our 0.35 air changes per hour in the home, that we know that we've done that in the right places. So from there, let's go ahead and take a look at some areas where we're going to want to really concentrate on air sealing to reduce the stack effect, the wind effect, and the mechanical effect. So here we are at a house under construction. We're going to take a look at some of the spots during this phase of construction where air leakage is most critical. We're going to take a look first at some places that haven't been hit yet, places we're going to need to concentrate on. Then we'll go through and we'll take a look at where they did do it and how they did that properly. We're standing right now in the garage where the heating system is located and the hot water heater. This is one of the most crucial points from the house to an outside space. One of the main reasons why? The heating system, everything that goes through this heating system is part of the house. So even though the ductwork may be in a crawl space, a garage, or an attic, the air that's in this ductwork is indoor air. So this is just as critical, if not more, than a regular leakage point in a home. We've got a couple items we'll point out, since we're standing right here, that are pretty critical. First is going to be the joint where the plenum for the furnace meets up with the cabinet. In most situations, this should be siliconed or mastic down. Should be sealed completely tight. In this particular case, they siliconed it, but it could use a little bit more work. Right behind me here, we also have a penetration that somebody's put through. Now, we're assuming that this is going to be patched over, but this is the kind of thing that at this stage of the game, this is when it should be sealed, so that we don't have to make any assumptions that somebody else is going to take care of this for us. This is a very classic and easy mistake for builders to make, and I see it on a very regular basis. Where plumbing penetrations from the garage go up into the home. This particular penetration, somebody attempted to seal it, but apparently some of the foam has fallen out from around that pipe. That is a direct hole to underneath the master bathroom tub, which means that the air underneath the master bathroom tub is going to be the same as the air in the garage ceiling here. This garage ceiling is an outdoor space. The master bathroom tub is an indoor space. That's something we're going to need to fix. Now we're going to take a look at some leaks from the other side of the garage. The garage is on the other side of us here. One of the reasons that I mentioned earlier the garage is one of the most critical points where we don't want air leakage coming in from is not only is it a cold space, but that's where we usually have combustion appliances as well as vehicles that are going to be parked in there and sometimes even idling in the morning before we go to work. So we want to make sure that carbon monoxide isn't going to be rolling into the house on top of the energy benefits. Some of the problems I'm finding in this room, and again, these are very common problems we see all the time. A large knockout has been made here. In fact, the entire block that you would normally see here has been removed for the plumbing to run through. Now, the reason that this is a problem is even if you didn't take this knockout out, with the advent of our I-beams that we've begun to use, we've left gaps through all of these walls. What that essentially does is that makes that ceiling in this room, once drywall is put on it, communicating with the ceiling in the garage. Now, the ceiling in the garage, because it's insulated, is designed to be an outside space. Therefore, this is designed to be an inside space, and the two should not be communicating. Ideally, this would be blocked around and sealed with foam, as would every single one of these joist bays. That is not only going to help us ensure that we get a good score on our blower door test and we actually meet our air changes per hour, it's also going to make this floor a lot more comfortable for people walking around on it upstairs. I also found another small item here in this room, and we also find this to be very common, where we've got wires running into an outside corner should always be foamed or packed with rock wool insulation to work as an air barrier. The reason why? This is an outside wall. If this were an interior wall, which we really often see, the air would be able to communicate and run its way all the way through, making this communication carry along, turning each wall successfully connected into an outdoor wall as well, air-wise. So this is very common. Even though these are both sort of outdoor walls, this should really be foamed anyway. One of the other important parts about air sealing is keeping our thermal and our air barriers aligned. What that means is where we want our air to stop moving, our heated portion of our air, that's where we want that to stop for our thermal reason as well. So that means our insulation should be lined up with our air sealing. This is a classic example of problems we see all the time where that's not going to happen. This is going to be an interior wall we have right here around this fireplace or gas place. But yet this wall, the exterior wall, is going to be what's insulated. Well, if you notice up here, you've got a pipe running along this exterior wall that is not insulated, foamed around up at the top here. That means air is going to be able to move around from this outside cavity all the way up into in between these floors and over, as well as making this entire section feel like it's an outdoor space. We have a thermal barrier there and have an air barrier here. When they're not aligned, we're not using our heating properly. So not only will this area be unaligned, the cold air from that outdoor wall will now be a part of this ceiling, which obviously can bring the cold air to the entire ceiling. That's what we talk about when we talk about aligning our thermal and air barriers. What we have here is a real common detail. We have an actual direct connection from inside the house to outside the house, where pieces of wood are sandwiched together and not quite tight enough. Now granted, there's going to be siding on the outside and we're going to have drywall on the inside, so this isn't going to show up real hot and heavy as an air leak on our blower door test. But when we talked about wind effect earlier and what that does to a house, any leak we have on our sides of our house, this is just a place where it's easy to get condensation or at the very least ghosting in the future, because this spot is going to be a little bit colder than the rest of it. Not only is it thermally weak because there's so much wood here, but now when the wind blows, we have a possibility for that air to come through and touch the backside of our drywall. This is the kind of detail you'd like to see caulked up at this stage of the game before we get too much further. I am standing in the crawl space, and I wanted to point out we've got a direct connection to the crawl space here where somebody put a notch in order to attach this strap. This is a point of direct leakage from the house into the crawl space. Crawl spaces and attics are unique zones. Unlike garages that we don't stand up and walk around in them, we don't park our cars in them, there's not going to be anything visual in there, and there's not going to be another layer of drywall. But they are just as important, if not more important, to perform air sealing in. Why is that? A couple things. One, the stack effect I talked about earlier in buildings, warm air wanting to rise, it needs to find a way to go out of the building. It's going to do that by traveling out through the attic if it can. What's going to happen when that happens? A negative pressure gets put on the building. It's going to want to pull some colder air in from somewhere else. That's going to be from the crawl space. Second issue, we like to put our ductwork in crawl space and attics to hide it out of plain view. Every piece of ductwork that goes into a crawl space or an attic should be sealed at every joint with duct sealing mastic. There are other forms that do work, but nothing works like duct sealing mastic. Duct tape, metal tape, all those other things, some of them aren't even on part of our state energy code anymore. So I would just really recommend using duct sealing mastic on any kind of ductwork that's in the crawl space, and really paying attention to any penetration that goes in and out of a crawl space or an attic. So these are the kind of leaks we can't afford to overlook. This particular chase poses three different issues. One, we've got a warm air heat duct running through here, and even though somebody had already had their tub of mastic out and was correctly sealing at the base of this shaft, they went ahead and used tape instead of mastic on the joints. Would have been an excellent opportunity to use mastic. The second thing is that this is an interior space, but it's connected to the attic. Up here, somebody foamed around here, but then similar to how they did when they went from between the house to the garage and they cut the hole out, here somebody's cut out a large hole to run the duct, put a metal flange around it, but then they didn't seal around the metal flange. So we've got some things they did right. They used some mastic in here, and some things that they've missed. This has not been sealed up at the top, and they used duct tape here. The reason why this is important, that stack effect we talked about earlier, the warm air wanting to rise, this is an easy location for warm air from inside the building to escape into the attic right around this duct. In addition, by this communicating with the attic, should the house go under a negative pressure, the fans are turned on, this is going to be an outside space surrounding a warm air duct. It's going to cause heat loss. It's going to make the whole place uncomfortable. Now we're going to take a look at some items that were done really well, nicely here, that are, again, very common, but it's good that these were done properly. Here we have a wall between the house and the garage. Not only have our penetrations been sealed, as they're supposed to, they've also been sealed as they're going down into the crawl space. And, as is the part of the code, the outside wall has been caulked along the entire bottom. That's going to make sure we don't have air coming in from these outer walls directly into our house. So this is an example of a wall that's been put together and sealed very well. Here's a detail this crew's done very well. They've sealed the back end of the electric box from the wall. Because normally you find that you can put a little electrical plate sealer from the front side to try and keep that air from entering the house. But this is really the ideal way to do it. During the framing phase, hit all the penetrations where wires are coming into these boxes that open directly to the house and seal them up. You can use caulking or foaming, mastic even if need be. But this is a detail I like that they've done very well in this house. Here's an item that's important to keep in mind. In this house they did a very good job of this. And that's the rough out connection that's cut open for where the heating registers are going to go. In this case, they've got it nice and nailed in tight, very little leakage around it. I'd still like to see any penetration like this sealed with either caulking, silicone, mastic, something like that, just to make sure. This particular case, though, as I said, this builder put this in very tight, this contractor did. So something to keep our minds open and our eyes peeled for. One of the other good items they did here is around these windows. It's another common air leakage site. Unfortunately, if you use expanding foam, you can ruin the warranty on several of these windows. So they did the preferred method. They used what is called a backer rod. What that is, it's a pre-made, encapsulated, almost sausage tube of sausage skin full of compressible foam that fits nicely and is tucked in around the window and then can be caulked into place before the trim is put up. Window was done properly. It won't have any leaks around it, and they didn't void the warranty. So now we've taken a good close look at some pluses and minuses we've seen in the air sealing here. We've seen some of the things that they did that I really liked, things that were completed in the right way, and some things that could use some help, just a little bit of work. These are all very common items we see in a lot of homes, both the good and the bad. What's important about this is now we had to get this message out so that not just the original builder, but also the subcontractors knows that when they cut a hole in something, when they put two things together, they should be sealed, and I mean, it's going to keep this whole house consistently tight. So now that we've seen this, we've seen everything we like, the things we don't like so much, why don't we go take a look at a house that's complete, do a blower door test on it, and see how we wound up. So our state energy code and the Northwest Energy Star certification regulations all tell us that we need to be at 0.35 air changes per hour for home leakage. Well, that's well and good, but how do we actually know when we build a house that we're achieving 0.35 air changes per hour? Well, we're going to use this contraption. This is a blower door. This is the Minneapolis blower door. What we do is we set this up on an exterior door. We're going to depressurize the house using this large fan to a preset industry standard pressure. use our digital manometer here to read the pressure difference between inside the home and outside. And then we're also going to use it to measure the flow of air through the fan. If we know the flow of air through the fan at this preset pressure, we can simply change the cubic feet per minute of air coming through here to air changes per hour for the whole house. With a simple calculation, find out, is this house really at 0.35 air changes per hour? So with that, we're going to go over here, turn the fan on, and make sure this house is going to pass. So now I've got the house set to its negative pressure that we need in order to perform the blower door test. We've already done a calculation on the air leakage rate the home needs to be at in order to be 0.35 air changes per hour. That's about 2,700 cubic feet per minute. Right now I'm going to take a look at this, and it looks like this house is at about 2,400, a little bit under that cubic feet per minute. So that's well below what we needed to be at to achieve 0.35 air changes per hour. If we actually extrapolate that out, we're probably at about 0.32 air changes per hour in this particular house. So that's what we do in order to do a blower door test. Simple, depressurize the home to the preset standard, measure the leakage rate here. Now we know the house is passed. We've achieved our 0.35 air changes per hour. Passed. But had the house not passed, one of the things I would do is I would take a smoke pencil here. This creates a relatively non-toxic smoke. You're not allowed to stick it up your nose, but in the general environment it's just fine. But the weight of this smoke is very similar to the weight of air. So I can go around to places where I suspect that air might be coming in, puff it into the air, and you can see in an area here where there's, other than my breathing, not a whole lot of air movement in this area. The smoke just kind of hangs in the air here. I don't know how well you can all see that. But if we come over to this door, for instance, I'm going to take a little piece of this tape off. You can see that smoke really blasts past. So it's a really good tool to use to move around. Can you get that okay on the... So what we're going to do is, just out of curiosity, we'll just kind of take a walk around the house. We're going to take a look at how effective they've been on the windows and on some of the other things they've done here, and see, this way we can kind of prove what a good job they've done. But this one was not sealed around, and you can take turns walking through here and just feel that air coming down.
Oh God.
Yeah.
That's amazing. Oh, yeah.
Yeah, so you can really tell in this kind of a setup how easy it is to find air leaks in a home if they're not properly sealed up. Wow. This test. So when you do the smoke test, the smoke won't even get close to it. So that's a real good definition of how it's done. On the other side would be to look around these windows where you would expect to find problems. You see that these are pretty well done. There's not a whole lot of air movement. There's a little bit coming up from right here. But all things considered, not a whole, not nearly like we see from over here. We have, and this is directly to the outside. That is going through the attic, which is going to be covered with insulation and all that. You can see that smoke blows that quite a ways. So
this should be pretty standard, these kinds of leaks in a standard home today.
Absolutely. This is extremely common to find. And this is a home that's passing, that they have paid attention to. So imagine homes where nobody has bothered to think this far ahead or to put any pressure to think about this. We found 3 or 4 things that really show up as leaks here in a house that we know is passing, in a home that would rate as quite a tight home. Most homes are dramatically over-ventilated, because their ventilation systems, often the installers who install the ventilation systems are not well versed and don't really know why they're installing them to be that way, and don't measure the rates on them to begin with, and just set them for 8 hours a day. And on top of that, they have all this natural building leakage. And the homes are over ventilated, pretty much so negating the majority of the energy factors they put into the home, bothering to have, why bother to put in a 90+% efficient furnace if you're going to leave the ductwork leaky and end up with a 50% efficient furnace? Same with the rest of your home. Why bother putting R38 in the attic if you're going to leave holes everywhere to allow air to go through? I want to talk a little bit about ventilation in homes. A lot of builders and homeowners get concerned that if a home gets built too tight, are they going to have enough ventilation? Are they going to have mold that's going to develop? Is the home going to feel stuffy? Is it going to feel uncomfortable to be in? So our ventilation there is there in the code that we're required to have ventilation in the state, and it's required to come on for 8 hours a day or a third of the time. There's several different ways that we're all commonly used to working with. The first is exhaust-only ventilation. I'm standing in a bathroom. We have an exhaust fan up here. What commonly is done is they will take advantage and put one of these on a timer and exhaust air out of the house. Well, even though that may technically bring our ventilation to where we want it to be, it does have some disadvantages to it. We could possibly be bringing air in from some of these places we don't want the air to come in that we talked about earlier. The second way commonly done is through integration with the furnace. That's what most people are real comfortable and common with nowadays. The timers that we use, there's been upgrades in the quality of timers that are used. There's the smart timer now that takes advantage of heating times to bring fresh air in. There's the use of humidistats, of carbon dioxide or carbon monoxide detectors in conjunction with these ventilation systems. They're all used to help kind of control the ventilation rate in a home. So the real problem here is not, are we going to build the house too tight? It's that, are we going to be able to put a ventilation strategy together with that is not going to be disabled by a homeowner because it's too loud or too uncomfortable or too confusing, and something that's going to be easy enough for us to follow as well as we put it together. So that's really what we need to remember when we're putting in a system. Build the house as tight as we need to, because if we're smart about our ventilation strategy, we're not going to have to worry about the house being too tight. So a few final thoughts to wrap up our day of blower door testing here. What we're really talking about are three things. One, the leakage that we have in our homes. Why is it there? Through the stack effect, the wind effect, the mechanical effect. All these things act different pressures on the home, cause air leakage. Second part is, what can we do about it? That comes in with air sealing and proper testing, like the blower door test that we've done today. The third thing we're going to go from is, what's going to happen after we leave? There we're talking about ventilation strategies. How can we set up a home so that it's friendly for the user, for the homeowner? We want to make sure it's non-threatening, doesn't make the home uncomfortable, doesn't create noise pollution, something that everybody can live with when we're done. And that really takes care of the three different steps we were looking at here today. Causes of the problems, what we can do about it, and how we can leave it for somebody else. If we keep those three things in mind when we do this job, everything should be just easy and fine. Thanks.